Hello and welcome to your third Deep Learning from Scratch tutorial. In this video I'm going to show you how to install Eigen, which is a linear algebra library, and then give you a sort of a crash course on everything about it. So let's get started. Go to your browser and type in eigen.tuxfamily.org. Now you want to download the latest release, and it's easier to get the zip version, which is here. So what is it really? It's a template, C++ template library for linear algebra. All the matrices, vectors, and so on. It's a pure header library, so that means you don't need to compile anything. All you need to do is include the header, and that's it, pretty much. The only thing it relies on is the standard library that comes with the C++ compiler. So that's pretty good. And also, when you're writing code, Eigen code, it's very readable because the way they use templates to make it. So let's just download the zip file. Now I've already done this, but you want to save this in your downloads folder, and when you've done that, open it up and extract it. Right click, extract all. Select the folder you want to extract to, and then press extract. So after you've done this, I'm going to show you how to set it up on Visual Studio. So go Visual Studio, and here we have it. Create a new project and call it, make sure you press empty projects and you're on this Visual C++ tab. And empty project, call it new net tutorial, and choose the folder and press OK. So one thing you need to make sure is that you change your configuration to whatever your machine should be. For mine is a 64-bit machine, and I'm just going to use the release version. And make sure you do this. Make sure you change the configuration before you do anything to the properties of your projects, because your properties are tied to your configuration. So if you change your configuration, you'll lose those properties, but it will be saved in that configuration. For that configuration. So let's change it. We can change it now, and let's first we have to include a main file. So do that. Then we want to right click on new net tutorial, properties, C++, additional include directories. Now down arrow, edit, and new folder, browse. We want to include our Eigen that we just extracted. Mine would be in my includes folder. And when you extracted your Eigen, your folder might have looked different from mine. Mine just says Eigen. Yours might have lots of numbers and letters after that, but I just renamed it to Eigen because it looks neater. And inside that folder, you would have a bunch of folders with one called Eigen with a capital E, but you want to choose this one, the previous one, the one that contains capital E Eigen. So do that, press select folder, OK, apply, OK. So now you should be able to include Eigen, and the library, the header file we're going to include is dense. Now there are other ones like hashtag include Eigen sparse. This is for a different type of matrix, for sparse matrices, but we're mainly going to deal with dense matrices. If you want to know what sparse matrices are, you should go to the Eigen documentation. They'll tell you all about it. So let's get started. So first thing is the main matrix that you're going to use is called first namespace matrix. Now this is capital X and then D. Now explain what this is. Capital X means the size of the matrix is unknown, and the letter is the type, so D for double, or you could have F for float. This is what you call a dynamic matrix. This is because it's unknown, X for unknown, and the size of the matrix is not set, and you can reset it during runtime of your program, and it can be reset at any time during runtime. That's why it's called dynamic, and it's resizable. On the other hand, you have fixed size matrices, meaning that you can't resize them. And they're written like this. So for convenience, we're going to include the using namespace Eigen. So you don't have to keep typing this over and over. We can just say matrix. Now, to define a fixed size matrix, they have a type depth between 2x2 matrix or 4x4 matrix. So a 2x2 matrix, you just put a 2 there, or 4x4 matrix, you say 4. And after that comes the letter for the type, and we're going to use, say, double. And F for fixed sized. And let's just use D for dynamic, so it's easier to remember. Okay, so when should you use a fixed size matrix, and when should you use a dynamic matrix? Well, I already said that the dynamic matrix is stored on the heap. The fixed size matrix, on the other hand, is stored on the stack, meaning that to access a matrix that's stored on the stack, it's a bit faster, just because of the way memory is stored on the stack. So when should you use a fixed size matrix? Well, if you have a matrix that you know what the size of it is, and the size doesn't change throughout the program, then you should use a fixed size matrix. Preferably, definitely use a fixed size matrix if the size of the matrix is 16 or less. So what that means is a 4x4 matrix. So 4 times 4 is 16. And you can find out what the size of the matrix by going f.size, and that will give you the size, and you can just print that out. Oops. Forgot to include iStream. This. And we want to see what we print out, so we're just going to say std cn.get. See if that works. Okay, so it says 16. So that means, yeah, it's a 4x4 matrix. That makes sense. 4x4 is 16. And that's how you get the size. So if the size of the matrix, if you know it's going to change, or if it doesn't change but it's going to be a big matrix, that is, when I'm saying big, anywhere above a size of 32 you should use a dynamic matrix. So, well, next, let's talk about resizing. How do you resize a matrix? Well, you can only resize a dynamic matrix, but you can actually apply it to a fixed size matrix and go 4 times 4. Now, you can do this. This is legal because you're not actually doing anything. It's already a 4x4 matrix. This isn't doing anything. But if you do something like this, that won't work, because yeah, this time you're actually resizing it. Just something fun to know about that. But to resize a dynamic matrix, you can just go resize, and then whatever you want. Yep. So how would you initialize a matrix such as this? Well, for a fixed size matrix, you can go insertion operator initializer. So you can initialize by typing numbers in like this, separated by commas. Now let's make this easier, so let's make a 3x3 matrix. So that's what we got here, and let's print that out. See what we get. Okay, so that's what we want. The way I inserted all these numbers is sort of the way it looks like, how the matrix looks like. So that's intuitive. Another way to initialize a matrix, you can go, if you want all the values in the matrix to be random, you can say, first you get the type name of that matrix. So in this case, it's a matrix 3D. Copy that and double colon, then type in random, and then that's it. You don't need any parameters. Let's see what we get. And you should get numbers between -1 and 1. So that's what we have here, and that works. What if you wanted to initialize random values for a dynamic matrix that doesn't have, the shape isn't initialized yet? Well, you have to define what the shape, you can define what the shape is in this random function. So you want a 4x4 matrix or a 5x5 matrix. Alright, so let's see if this works. Okay, so you get a 5x5 matrix where every value is between -1 and 1. So that works. If you have a matrix where the values are integers, the random function will make each value integer between the lowest possible integer and the highest. But you have to double check on that. I'm not too sure. But moving on, if you wanted to define the size of a dynamic matrix early on, you could do it when you declare it. So you can just say it here, 5x5, or anything you want. What if you wanted to initialize with a constant value? Well, you can say first the name again, the type name, type in constant, and then inside you want to put what the value you want to initialize every variable to be. So here I want to initialize everything with a 1. So it should be a 3x3 with a 1 for each value. And you can do that for anything you want. So let's see, what for a dynamic matrix, it's going to be sort of the same, but if the dynamic matrix is not defined, the shape is not defined yet, then you want to define it here. So let's say 5x5, and then the last parameter is what you want to initialize every value to be. So let's see if that worked. Oops, I forgot to change that. Here we go. So that works. Now, let's see what happens if you already defined the shape of the dynamic matrix. So let's say a 4x4 of doubles, and here you just want to initialize everything with a 1. Can you do that? No, you can't. You have to define the shape. So even if you defined the size of the dynamic matrix beforehand and you want to initialize it again with a constant value or a random value, you always have to define the shape again here. And if you have a different shape from before, it will resize it. So I think this would work. So now it's a 5x5. So what if you wanted to make your own customized fixed size matrix? Because right now you could either make a 2x2, a 3x3, or 4x4. And you don't have a 5x5 either. So how do you do this? Well, you can use the matrix class. So the matrix is like this. Say the name, type name, and then the number of rows and columns. Or you could say 3x3. So this is actually the same as this. What if you wanted a dynamic matrix? Well, you just use the keyword dynamic. And this would be the same as matrix XD. So what they did actually, I think they just type defed it, and said this was this, something like this. Anyways, alright, so let's talk about how you would multiply two matrices together. So let's say you have a matrix defined like this. So let's call that M1. It has 1 row and 2 columns, and we're going to initialize it with 2 values, like so. And let's make another one. A 2x2 matrix, call it M2, and we'll initialize it like this. Okay, so matrix multiplication is pretty simple. It's just like you're using normal variables. All we have to go is okay, so this would work. Let's see what that prints out. It's got a 7 and a 10, which I think is the correct math. Let's see what happens if we swap these two around. Would that work? Okay, so it says invalid matrix product, and I'll show you why in a sec. Okay, so we define the two matrices like this. First one is 1 row, 2 columns, and you got a 1 and a 2. And then the second one we have a 2x2, and where we have 1, 2, 3, 4. And so the first matrix has 1 row, 2 columns. So let's write it down. The second one is 2x2. Let's look at the inside numbers. They're the same, so that means these two matrices are compatible to be multiplied with each other. If what we just did just then, we swapped these two around like that, and now what happens is that the two inside numbers are not the same, and so multiplying it like this is not gonna work. So that's what happened there. Let's say there's a different type of matrix called a vector, and vector is basically means that it has one. It's basically a matrix, but it means the number of columns is 1. So let's define M1 as a vector, and we're going to say it has 2 values inside, and we're going to initialize M1 the same way. Now let's turn this back like this. Would this work? Okay, so it says invalid matrix product again because what happened there was when we define vectors in Eigen, that by default the vectors are vertical. So what we defined then was like a vertical matrix like this, and we were trying to multiply these 2 matrices together. And so we have 2 rows and 1 column and a 2 by 2. So you can see again that the inside numbers are not the same. So this wouldn't work unless you were to swap them around. Then that would work because inside numbers are the same. Let's see. What if? So how would you fix that? What we can do is say transpose. Now, I don't know if you know what it means, but it basically means that with a transpose, it's what the rows, the first column of a matrix becomes the first row of a matrix, and vice versa. So a 1, 2 vector transpose is equal to a 1, 2. Also, if you have a 1, 2, 3, 4, if you have this matrix, the transpose would be 1, 3, and a 2, 4. So 1, 3, the column becomes actually the row. 2, 4 becomes 2, 4, the row. So I hope that makes sense. Now let's talk about how you would perform non-linear algebra operations on a matrix. Well, you can't. You have to convert the matrix to an array type. And to do that, let's try to do that. Let's first comment this out, and so let's say you wanted to add M1 matrix plus 1. Now this wouldn't work because M1 is a matrix, and let's say we want to add each element in M1 by 1. This wouldn't work. It would cause an error because this is not linear algebra. So we have to convert the matrix to an array by simply going like this. Now this should work. So we had 2, 3. So we added 1 to the 1, 3, and now it works. So Eigen has a whole bunch of math functions. You got exponential, sine, asine, tan, abs, everything. So even if we wanted to go exp, that would work. But taking away the array wouldn't work. Wouldn't make this work. So basically what this does is it converts an array so that you can form arithmetic on the matrix element-wise. So that's really helpful. So that's about that for the Eigen library. I should get you started with this, given this crash course. Well, anyways, thanks for listening, and I'll see you in the next video.